Alright guys, today we're going to be solving a question called majority elements. It's LeetCode easy. Let's go ahead and dive right in. I think they wanted us to solve this. I remember reading somewhere. Let me see. I haven't solved this before, but we want to solve it in linear time in O1 space. So solve, let's see, let's write this. Oops. Okay, let's see. In O of n, that's linear time, and using O of 1 space. Let's see if we can solve this. So we see in this problem, let's see. Actually, let me decrease this. Okay. So we see in this example, there's 3, 2. So there's 3, 2, 3. And this is our array. We just want the number which shows up n. So n would be equal to 1, 2, 3, 3. So we have to find the element that shows divide by 2. We want to show the element that points 1 or more times. In this case, 3 shows up 2 times, and 2 is greater than 1.5. So that's why we could go ahead and return 3. Okay. How can we solve this? I think, I guess we could have a counter, but that would actually, we could have a counter, so something like this, which is like a hash map. It'll have numbers, it'll have every single thing, so we'd have 3, and it'd be mapped to 2, because 3 showed up 2 times, and we'd have another one where 2 is mapped to 1, because 2 shows up 1 time, right? 3 times, and 2 shows up once, 1 time. It's supposed to say 2. Okay, so that's not a really good solution, so try to find a different solution, one that was better. Okay, let's see. So we're given, let's try to think of a better use case. This was 2, write this out. 2, 2, and then a bunch of 1s, okay. 2, comma 2, comma 1, 2, 3, 3 1s, and then put 2 more 2s, 3 more 2s, I mean. Okay, so for this one, we know that there's 2s and there's 2 3s. So that's a total of 5 2s. And there's 3 1s. Okay. So we have to find a way where we could kind of count. So let's see, number 1, use O of 1 space. And second of all, we have to do O of n runtime. O of n means we only look through the array once, so I'm going to just translate that. Note. Want to go through array once. Let me see, 2-pointer strategy. We could have 2 pointers on each end if 2 matches 2. I guess we could increment it. No. Let's see. I know counter would work, but counter is not what we're looking for. Let me compare. Hmm. We could run like a max operation. No, that wouldn't work. Okay, set. Yeah, I think we could get the total size. So n will be equal to 3. And if anything is equal to n over 2, then we could go ahead and just return that. Hmm. So to count this, this would just be like 2. We'd have things like that would be possible. That's being O and M solution, right? But it would be at O of n over 2, and that's not. Oh man, alright, I'm just gonna try to solve this the regular way with a counter. Okay. Okay, let's see. No, we want ceiling division. Actually, it doesn't matter. Okay, and now after running this, we could say I think it would run faster if we do this. If counter number is greater than or equal to return number. I think this should work. Okay, so for each number in numbers, if the number is not in counter, we increment it by 1. We go ahead and initialize as 1. Otherwise, we have a counter as 1. Okay. Oops, misspelling. Yeah, but it's not the solution we're looking for. Okay, let's go try to look up the solution of the optimal solution. Okay, so we traverse there, right? If count is equal to 0, set candidate to current element. If current element is equal to candidate count plus else minus y. Okay. Whoa, okay. Okay, so count is equal to 0, candidate is equal to none. If the number in nums, if count is equal to 0, candidate is equal to number. Count plus equals 1 if num equals candidate, else -1. Do we just return candidate? Okay, let's go ahead and draw this out. Draw out the solution. Let's try to understand it. Let's go ahead and grab our eraser. Actually, let's go ahead and move. Okay, back to drawing. Okay, cool. Okay, let's go draw our test case. 2, 2. Okay. So for this test case, we're gonna use a darker color. Whatever, okay. So 1, 1. Okay, let's see, 2 1s, okay. Okay, so count's gonna be equal to that for each number in nums. Let's say this one. If count is equal to 0, count is equal to 0, candidate is equal to num. So we're gonna have a variable called candidate. and that's going to be equal to count is equal to 0. Okay, candidate is equal to number. So candidate's 1, candidate is equal to 1, count plus equals 1. So now count is going to be equal to 1. See, it's number. Number is equal to candidate in this situation. Okay, now we run it for the next element. So 1 would be count is not equal to 1, but okay, count is plus equal 1 if numbers is equal to candidate. So now count is 2. And we cross this out. Okay, count is equal to 2. Else negative 1. So count's going to be negative 1 now. Minus 1. So count will now be equal to 1. Oh, so we're basically canceling them out. So, oh, I get it. I think I get it. Okay, so we're basically going to have something, let's say, 1, 1, 2, 2, 1, 1, 1. So we're going to have a count going to be equal to 0, right? But after processing this, count is going to be equal to 1, right? And then after processing this, count's going to be equal to 2. And now we process the next one, so count is going to be equal back to 1. And then count is now going to be equal to 0. Now count is going to be equal to 1, and then 2, and then 3. And then now we just return candidate. I get it. So you're kind of comparing each count to each cells. So instead of, okay. So our initial idea, we were going to count every number, but in this idea, we subtract. What if we have different numbers, though? Let me think. So it would have to be, okay, 1, 2, 3, 4, 5. So this would have to be 3 and above. So this is invalid. 1, 2, 3, 4, 5, 6, 6. Is an array like this invalid? Let's see. Okay. Okay. Okay, let's go. we don't really care about the length of nums. We just say for number in nums. It's going to be equal to count. No. So now the candidate is going to be equal to number. We do count plus equals 1. Do count. We could say something else. Let's say if count is equal to 0, equals a number, count plus equals 1. Let's say if your number equals candidate, count plus equals 1 else. If this number is equal to a candidate, then go ahead and count. Okay. Okay, let's go submit. And we did it. That's how you solve it. I think it was different than this code, but see, what did this code do? I use more if statements. It said for number in numbers, if count is equal to 0, candidate is equal to number. Okay, that's true. Oh yeah, I basically split this one into 2. But yep, that's how you solve, what's this question? Majority element. Thank you guys for watching.